We are stardust, the universe made self-aware, forever gazing upward in search of our origins. For millennia, we've built tools to extend our senses, each one bringing us closer to answering the biggest questions. Where did we come from? Are we alone? The James Webb Space Telescope is humanity's golden eye, a time machine of mirrors and detectors, sent 1,000,000 miles from Earth to capture the faint, ancient light of the first stars and galaxies. Its mission to witness the cosmic dawn, to see the universe as it was over 13 billion years ago. Webb orbits the sun, shielded from its glare, allowing it to detect the faintest whispers of heat from the distant past. Think of it as an archaeologist of light revealing the universe's earliest foundations. Every photon Webb collects is a clue in the grandest detective story ever told, the birth of everything we know. Each new data release sends ripples of excitement through the scientific community. We point Webb at a tiny patch of sky, wait, and then the data streams back, painting a universe we've only dreamed of seeing. Each observation is a gamble. Will we confirm our theories, or find something that shatters them? Webb was built to answer specific questions. How did the first galaxies form? What are the origins of stars and planets? Could there be signs of life on distant worlds? But the universe is under no obligation to make sense to us. While Webb checks off its to-do list, it also stumbles upon the unexpected, discoveries that redefine our understanding. These are the moments that truly define an era of discovery. With every image, Webb brings us closer to understanding our place in the cosmos. The universe is more surprising and magnificent than we ever imagined. And with Webb, we're just beginning to turn the page on a new chapter of cosmic history. Every great exploration is defined by the unexpected. We build theories, run simulations, and expect the universe to follow our script. The James Webb Space Telescope was meant to confirm our elegant models of cosmic evolution. But the universe loves a plot twist. Before Webb, our view of the early universe was blurry. Hubble gave us glimpses enough to sketch a rough timeline. We thought the first galaxies were small, messy, and faint, slowly merging over billions of years into the grand spirals we see today. The expectation, a universe in its infancy, just learning to walk. Instead, Webb delivered a shock. Its first deep-field images revealed objects that shouldn't have existed, galaxies that were too big, too bright, too well-formed for their age. It was like finding a fully grown adult in a nursery of newborns. The universe, it seemed, had learned to run before it could crawl. This was more than a whisper of the unexpected, it was a thunderclap. Scientists were stunned, theories were challenged, and the story of cosmic evolution began to change. The tension between theory and observation became palpable. Webb's discoveries forced us to question everything we thought we knew. The universe had rewritten its own origin story, and for astronomers, this was the most exciting plot twist of all. The search for answers had only just begun. So, what did Webb actually find? Galaxies that were far too massive and mature for their age. Imagine looking back to when the universe was just 500 million years old, expecting to see cosmic infants, but instead finding giants as massive as the Milky Way. These universe-breaker galaxies challenge the very foundations of our standard model of cosmology, known as lambda CDM. According to this model, galaxy formation should be slow and gradual, taking billions of years. Yet Webb's data shows these behemoths shining brightly at the cosmic dawn. It's like finding a skyscraper in ancient times, completely out of place. Scientists checked and rechecked the data, but the conclusion was inescapable. The early universe was far more efficient at building galaxies than anyone predicted. This isn't a minor tweak, it's a potential paradigm shift. Are our ideas about dark matter wrong? Does gravity behave differently on cosmic scales? Or is there an unknown force at play? These questions don't have easy answers, but they push science forward into uncharted territory. Webb's discoveries have cracked open the door to a new era of cosmic exploration. The universe is more mysterious and more fascinating than we ever imagined. To grasp the scale of this disruption, compare the old story to the new evidence. We thought the early universe was a patient builder, gravity slowly pulling gas into small, faint galaxies over hundreds of millions of years. Our models predicted a bottom-up process, tiny piles of cosmic sand gradually forming grand castles. But Webb found fully formed castles, massive, organized galaxies just a few hundred million years after the Big Bang. Some even appeared as disk galaxies, a level of structure thought to take billions of years to develop. This suggests galaxy formation might be more top-down, or that there's a fast track we never imagined. The early universe wasn't a quiet nursery, it was a bustling, hyper-efficient factory for building galaxies. If galaxies formed this quickly, the conditions for stars, planets, and maybe even life could have emerged much earlier than we thought. This changes our entire mental picture of the dawn of time. The universe, it seems, was in a hurry to light up the darkness. Imagine the universe as a cosmic kitchen, the laws of physics as the cookbook. The old recipe for galaxy formation was a slow-cooked dark matter and gas, simmered gently for billions of years, forming small clumps that merged into galaxies. Webb sent back a picture of a fully baked, multi-layered cake just minutes after the oven was turned on. Did we misread the recipe? Is there a secret ingredient, a cosmic yeast that makes everything rise incredibly fast? The discovery of these impossible galaxies forces us to question the entire cookbook. Maybe our understanding of dark matter is incomplete, or just plain wrong. Scientists are scrambling for new recipes. Perhaps the seeds of galaxies were larger, or the first stars were massive and short-lived, creating black holes that rapidly built galaxies around them. Each new idea requires us to rethink fundamental parts of our cosmic cookbook. The implications ripple through everything we thought we knew. The universe's recipe is more complex and more surprising than we ever imagined. The reaction to Webb's discovery has been a mix of excitement, disbelief, and frantic activity. In universities and research centers, it's the topic of emergency seminars and late-night debates. For scientists, this is the holy grail, a crack in our knowledge and a chance to peer into the unknown. The first instinct was skepticism. Could it be an error, a misinterpretation, or something else entirely? Researchers rigorously tested the data, using Webb's instruments to confirm distances and analyze chemical makeup. So far, the evidence holds up. These are cosmic titans in the universe's infancy. The skepticism is giving way to awe, and a race to explain the inexplicable. For the public, the headline is irresistible. Telescope finds galaxies that shouldn't exist. It sparks wonder and curiosity, reminding us that the universe is still a living mystery. This discovery could even impact the search for life. If galaxies, stars, and planets formed earlier, the window for life to emerge is wider than we thought. The universe feels bigger, older, and more filled with possibility than ever before. Webb's findings connect us all to this grand adventure of discovery. Why does this matter? Because exploring the cosmos is exploring our own origin story. These discoveries are not just data, they're pieces of our collective identity, connecting us to the universe and to each other. The James Webb Space Telescope is a monument to human curiosity and ingenuity. Every image, every discovery is a return on our investment in wonder. Webb inspires new generations of scientists and dreamers, reminding us that the universe is far from fully understood. The story of the universe-breaker galaxies is just the beginning. Webb has only scratched the surface of what it will reveal. We are living in a golden age of cosmic discovery with a front-row seat to the unfolding story. The universe is not a finished book, it's a story still being written, and what we're finding is more spectacular and mysterious than we ever imagined. The journey has just begun.